Very good afternoon, everyone. I welcome all of you for Day 12 GATE online training program. And today's session will be delivered on concrete structures and water quality. So concrete structures, the session will be handled by Professor Arjun, and the session on water quality will be handled by Professor Shilpa BS. So here is the brief introduction about today's speaker of first session on concrete structures, Professor Arjun sir. Professor Arjun is an assistant professor in Department of Civil Engineering with more than 6 years of experience in Vidyavardhaka College of Engineering. He is actively involved in teaching structural subjects, offers consultancy on testing of construction materials, and is in charge of concrete laboratory. He will be speaking on fundamentals of concrete structures required for cracking problems related to GATE examination. Over to you, sir.
Thank you, madam. Share the screen first. Hope my screen is visible.
Yes, sir. It's visible and audible.
Okay. Very good afternoon to everyone. Welcome to the GATE training program, 12th day, and the session 3 of concrete structure. In the previous 2 sessions, we have discussed about the singly reinforced sections, doubly reinforced section, and solved the few problems related to singly and doubly reinforced section. Also, we cover the what are the various aspects to be remembered in case of singly and doubly reinforced sections. So basically, in numerical problems, you have to remember the equations of neutral axis, equation for depth of neutral axis in case of singly and doubly reinforced section, and also you should remember the moment of resistance formula in case of singly and doubly reinforced sections. So we have solved several problems related to singly and doubly reinforced section, and also we discussed about few parameters that has to be remembered, which can be asked for 1 mark questions. So those points to be remembered have been discussed, such as minimum amount of AST to be provided in case of beam, and what is the spacing of shear reinforcement to be provided, and what are the development length, how the variation of development length can vary along the length of the bar, that we have discussed, and we discussed few previously asked questions related to those topics, and also we discussed about certain aspects of certain design aspects of slabs, such as how to find out the effective span for simply supported continuous slab and cantilever slab, and also we discussed few design parameters such as one-way. What is the difference between one-way slab and two-way slab, how to provide the reinforcement, and also what are the minimum requirement, such as minimum amount of steel in case of mild steel and HYST bars, that has been discussed, and also we discussed about the maximum spacing allowed in case of main reinforcement and distribution reinforcement. Along with that, we discussed the torsional provisions in case of slabs, when the slabs are partially or completely restrained against the rotation. Okay, so and also we discussed about certain aspects, certain important definitions and IS recommendations of columns, and various types of columns, such as axially loaded column, axial load with uniaxial moment, and axial load with biaxial moment, that we have discussed in the previous sessions. So coming to the today's session, the very important parameter which is required in solving the problems related to columns are, most of the time in case of columns, the questions or the problems usually pertaining to axially loaded column only, because in order to solve the problems related to uniaxial column and biaxial column, most of the time we require the SP16 for the interaction curve. Okay, so in order to, since the SP16 is not allowed in case of gate examination, so you can expect the problems related to axial columns only. Okay, so the very important formulas to be remembered is, first one is the compression carrying capacity of the column pu is given by sigma cc into ac plus sigma sc into ac, where sigma cc is the design strength of the concrete. So the design strength of the concrete from the stress block parameter was found to be 0.446. So that's why this equation will become 0.446 FCK AC. And the design strength of the steel, generally in case of axial compression, the design strength sigma sc or allowable strength in case of column is generally considered as 0.7 times of fy. Okay, 0.75 times of fy is the allowable stress in case of axially loaded column. Uh, so generally in case of bending, we were considering the sigma sc as 0.87 times of fy as the design strength of the concrete during the bending, but in case of axial compression it will be 0.75 times of fy, so which is multiplied by corresponding cross sectional area of the compression reinforcement will give the total compression carrying capacity of the column, because the compression load will be shared by concrete as well as the steel reinforcement. So in order to get the total compression carrying capacity of the column, we should take the summation of the compression carrying capacity of the concrete and compression carrying capacity of the steel. So this equation, so generally 0.446 is round it off to 0.45 FCK. So this is the equation in order to determine the compression carrying capacity of the column when there is no minimum eccentricity, when there is no provision for, if they mention neglect the minimum eccentricity condition, then we can use this formula. So most of the time while designing a reinforced columns, we generally we will design it for a minimum eccentricity of 20 mm or unsupported length divided by 500 plus lateral dimension divided by 30 will be the, out of whichever is maximum, that will be considered as minimum eccentricity for which the column will be generally designed. In such a cases, pu is always considered as 90% of the equation 1. So if you multiply 0.9 to the 0.45, you will get 0.4 FCK. And if you multiply 0.9 to the 0.75, it will give 0.67 FY. Okay. So this is the equation in case if you consider the minimum eccentricity into the account, we have to use the equation number 2. If we neglect the minimum eccentricity, then we have to use the equation number 1. So generally when E minimum is less than 0.05 times of least lateral dimension, then use the equation. If E minimum is greater than 0.05 times of least lateral dimension, then use the equation number 1. Okay, so some of the IS code recommendation what we discussed in the previous class was we should provide the minimum least lateral dimension. That means if you consider B and D, the minimum value of B and D should be equal to 200 mm. So in no case it should not be less than 200 mm. And minimum nominal cover should be greater than 40 mm for columns. However, it depends upon the fire rating, endurance time, and also it depends upon the environmental conditions. So that has been mentioned in the IS code book, IS 456. and the minimum diameter of the longitudinal bars in case of column should be 12 mm. So the minimum diameter of the compression reinforcement in column should be greater than 12 mm. Okay, so in case least lateral dimension less than 200 mm, a nominal cover may be reduced to 25 mm with the appropriate precautions. Okay, so the minimum diameter of the longitudinal bars can be less than 12 mm in case if the cross section least lateral dimension is less than 200 mm. So but code specifies we have to provide a minimum lateral dimensions of 200 mm. Okay, and the minimum amount of compression reinforcement to be provided in case of columns are 0.8 percentage of gross area, that is 0.8 by 100 into B into D. So this is the total minimum amount of compression reinforcement to be provided in case of columns. So maximum of 6% gross area is allowed when the bars are not overlapped. That means if you have a 2-floor building, you have to provide a single reinforcement. That means if you are providing 6 bars of 20 mm dia, if you are providing 6 bars of 20 mm dia throughout the 6 meter, say example each floor is 3 meter height, throughout the length each bar should not be cut and spliced by another reinforcement. So when there is no splicing of reinforcement, we can provide the 6 percentage of the compression reinforcement. Whenever we in general reinforcement are generally spliced. Okay, they are overlapped, so generally the compression reinforcement is restricted to 4%. Why? Because whenever there is a splicing of reinforcement, okay, whenever there is a splicing of reinforcement, while pouring the concrete, the larger aggregate may struck here, so which avoids the movement of the concrete into the cover portion. So thereby the durability of the structure increases and also the strength of the concrete decreases. In order to, from this practical point of view, generally the maximum amount of compression reinforcement is restricted to 4%. And in case of circular section, whatever may be the section, you should provide a minimum of 6 bars in the whatever may be the diameter of the section, you have to provide a minimum of 6 bars reinforcement. Okay, so we have to provide a minimum 6 bar reinforcement in case of circular columns. In case of square columns or rectangular columns, the minimum number of reinforcement is 4 numbers. Okay, and also the spacing between the bars shall not be greater than 300 mm. So in any case, the spacing between the bars of a longitudinal reinforcement should not be greater than 300 mm. Okay, and generally the diameter of the lateral ties depends upon the diameter of the reinforcement to be provided. It depends upon the diameter of the longitudinal reinforcement. Generally, we will consider the diameter of the reinforcement as lateral reinforcement as greater than 1/4 of the longitudinal reinforcement. 1/4 of the longitudinal reinforcement, say example, or 6 mm, whichever is greater. Say example, if you are using 32 mm diameter as the main reinforcement or the longitudinal reinforcement, then the lateral ties should be used is 8 mm. Okay, so you should not use less than 8 mm lateral ties. Generally, the lateral ties are provided in order to which hold the longitudinal bars in position, so that the longitudinal bars does not deviate or get deflected if the longitudinal bars get deflected, generally the column position slightly shifts. So whenever we load the columns, what happens? It will act at a certain eccentricity, so for which generally we were not designed. So in such a cases, the failure may happen. So in order to avoid that, we should provide a proper lateral ties. Okay, so lateral ties will uh, hold the longitudinal reinforcement in position. Okay, so the maximum pitch of the transverse reinforcement the pitch is nothing but it is the spacing between the lateral ties. So spacing between the lateral ties should not be less than should be always lesser of the following. First one is 16 times of longitudinal diameter. Suppose if you are using 16 mm diameter, then 16 into 16, it is 256 mm. Center to center will be the pitch. If it is 300 by 600 mm column, so lateral dimension is 300 mm, least lateral dimension is 300 mm, and again 300 mm. If you are using 16 mm dia bars, the minimum lateral ties will be 6 mm. So, or you can consider 48 into 6. So out of these four values, whichever is minimum, that should be considered as the pitch value. Okay. So here in this case, it is 256 mm center to center. Generally, we will round it off to lower value in the multiples of 5 or 10s. Okay. So generally, we will provide a 250 mm center to center in such a case. In this case. Okay. So these are the some of the recommendations that has been provided by the IS code. So coming to the few questions that has been asked in the previous gate questions, the question goes like this: the lateral ties in a reinforced concrete rectangular column under axial compression are used to, first one, avoid buckling of the longitudinal steel under compression. Second one, provide adequate shear strength. Third one, provide adequate confinement to concrete. Fourth one, reduce the axial deformation on the column. So if you look into the option A, avoid the buckling of longitudinal steel under compression is the right answer actually, because the lateral ties are provided in order to hold the longitudinal bars in position. Okay, so that means it should not buckle or it should not deviate. So answer 1 is correct. So if you look into the answer 2, provide the adequate shear strength. No, the lateral ties won't increase the shear strength. It is not provided in order to provide the adequate shear strength. So this is wrong answer. And also if you look into the option C, provide adequate confinement to the concrete. No, because lateral ties are provided in order to confine the reinforcement, not the concrete. In order to confine the concrete, we will provide the formwork. Okay, so reduce the axial deformation. No, axial deformations are not reduced, cannot be reduced in columns. So the correct answer is option A, avoid the buckling of longitudinal steel under compression. Okay, so in reinforced concrete, pedestal is defined as the compression member whose effective length does not exceed its least lateral dimension by option A 12 times, option B 3 times, option C 16 times, option D 8 times. So the correct answer is option B 3 times. Because the pedestal is a short compression member whose effective length is less than 3 times of least lateral dimension. Okay, whose effective length is less than 3 times of least lateral dimension. Such a members are called as pedestal. If it is greater than 3 times of least lateral dimension, then we will call it as column. Okay, so that's why the answer is option B, 3 times. So there is a one problem related to eccentricity. So as I told you in the previous slides, what is the formula for eccentricity? So in order to determine the eccentricity, E minimum is equal to unsupported length divided by 500 plus lateral dimension divided by 30. So the or 20 mm, whichever is greater, that should be considered as eccentricity. So if you want to compute the eccentricity, let's look into the problem. A column of size 450 mm by 600 mm has an unsupported length of 3 meter. Okay, so cross section dimensions are given 450 mm by 600 mm. Okay, and the length of the column is unsupported length of the column is given as 3 meter. Okay, and is braced against side sway in both direction. According to IS 456 2000, the minimum eccentricity with respect to major and minor principal axes are dash. So option A 2020, option B 26 and 21, option C 26 and 20, option D 21 and 15. So in order to solve these type of problems, we should know which is the major principal axis and minor principal axis. So the major principal axis means the axis which is parallel to maximum dimension will be considered as major principal axis. Okay, so in this case parallel to 600 mm, whatever whichever is the axis is there, that should be considered as major principal axis, and this one is minor principal axis. Minor principal axis. Okay, so while considering the major principal axis, so we know that E minimum E is equal to unsupported length divided by 500 plus lateral dimension divided by 30. That should be the equation for E. So while considering the major principal axis, so for this axis the lateral direction is 450 mm. Okay, for this axis the lateral dimension is 450 mm. So considering that, so unsupported length is given as 3 meter. Okay, sorry. Minor. Okay, 600, 450. Okay, so formula for E is 3000 divided by 500 plus lateral dimension along the major axis is 450 divided by 30. So it will be 3000 by 500 is 6 and 450 divided by 30 is 15. Okay, 450 by 30 is 50. So 6 plus 15 is 21. Okay, so eccentricity with respect to minor axis is 21 mm. Okay, then with respect to major axis, if you compute the E, 3000 divided by 500 plus 600 divided by 30. So this is 6, this is 20, it will become 26. So 26 and 21 is the correct answer. So option B will be your correct answer. So option B is the answer for your value. Suppose if you get it as 19, then you should consider the minimum of 20 mm. So in such a cases, 26 and 20 will be the equation. 26 and 20 will be the correct answer. Okay, so similarly, one more question was asked in the GATE examination related to finding the ultimate load carrying capacity of the column. Okay, so what is the question? A RC short column with 300 mm by 300 mm square cross section is made up of M20 grade, has 4 bars. Okay, so 300 by 300 mm. So it is under the action of axial compression with a minimum eccentricity. So whenever they are saying with minimum eccentricity, then you have to use the equation Pu is equal to 0.4 times of FCK AC. If they mention neglecting the minimum eccentricity, then you should consider PUZ is equal to 0.45 FCK AC plus 0.67 FY, sorry, 0.75 FY AC is the equation when we neglect the minimum eccentricity. Here they are mentioning that under the action of axial compression with minimum eccentricity. So we have to use the equation Pu is equal to 0.45 4 FCK into AC plus 0.67 FY AC. Ignoring the reduction in concrete due to steel bar. Generally, in order to find the concrete, the total gross area is equal to area of concrete plus area of steel. Okay. So if you want area of concrete to be substituted here, we will deduct the area of compression reinforcement, from the gross area in order to get the AC. Okay. So what they are mentioning is ignoring the reduction in area. So we have to ignore the reduction in area due to steel bars. That means AG is equal to AC. Okay, AG is equal to AC. So then what is the ultimate load carrying capacity of the column? So in order to do that, substitute everything is available 0.4 into what is the value of FCK? FCK is given as M20. Since the grade of concrete is 20, FCK is 20, AC is nothing but you can directly consider 300 by 300 plus 0.67 into Fy value is grade of steel is given as Fe415. So 0.67 into 415 into area of steel compression reinforcement is given as 4 into pi into 20 square by 4. Okay, so if you simplify this, you will get the value of Pu as 169.2 kilonewton. So the nearest value is 1069 kilonewton. So your answer is 1069 kilonewton. That is option D is the right answer. The next problem is an RCC short column with lateral ties of rectangular cross section in 250 cross section of 250 by 300 mm is reinforced with 4 number of 16 mm dia bars. Okay, so they are mentioning that 4 bars of 16 mm dia bars are used as the reinforcement. Okay, the grades of steels are Fe415 and M20 respectively, neglecting the eccentricity effect. The axial load carrying capacity of the column is dash. So that, as I told you in the previous problem, whenever they mention neglecting the eccentricity effect, you should consider the equation Puz is equal to 0.45 FCK into AC plus plus 0.75 Fy into AC. This will be the equation for compression carrying capacity. Okay, so if you substitute in this equation, we know that 0.45 FCK is 20 area of concrete. Here they are not mentioning that neglect the reduction of concrete due to provision of the steel. So you have to consider AC is equal to AG minus AC. Okay, AG minus AC. So AG is nothing but 250 by 300 minus area of steel is 4 bars of 16 mm dia. 4 parts of 16 mm dia plus 0.75 Fy is 415 and AC value is 4 into pi into 16 square by 4. Okay, so if you substitute in this equation, the answer will be 250 into 300 minus 4 in 16 square plus 0.75 into 415 into so answer will be it is PUZ will be 918.08 kilonewton. This is the answer for the current problem. So moving on to next problem. While designing for steel column of Fe 250 grade, so you might have wondered why they are mentioning the steel column in case of concrete structure. So read the questions fully. So while they are mentioning that while designing the steel column of Fe 250, a base plate resting on a concrete pedestal. Okay, so concrete pedestal means whenever we want to erect the steel column, we require the foundation. So generally the foundation will be of reinforced concrete. When the height when the least lateral dimension is three times the least lateral dimension is less than the height of the compression member, it is called as pedestal. So such concrete pedestal of M20 grade is provided. The bearing strength of the concrete in limit state method of the design as per IS 456 2000 is dash. So in order to find the bearing strength as per the limit state method, we know that the design strength is nothing but 0.446 FCK, or if you substitute permissible stress as 0.45 times of FCK, so FCK is 20, so 9 Newton per mm square. 9 Newton per mm square is the permissible bearing strength of the concrete, or the bearing strength of the concrete is 9 Newton per mm square. So this is how you have to calculate the values. So if they ask in case of working stress method, you have to consider sigma CBC divided by 3, because CBC is nothing but permissible stress. Permissible stress is depends upon the grade of concrete. So how to find out sigma CBC? So sigma CBC is nothing but FCK divided by factor of safety. So factor of safety is 3 for working stress. So in such a case, 20 divided by 3, that is 6.67. Okay, that will be the bearing strength in case of working stress method, that you should remember. Okay, next, this is about the few problems that may ask. These are some of the problems that has been asked in the previous GATE examination. So moving on to the very important aspects, or some of the important aspects which is comes under IS 456, or first one is mixed proportioning. Generally we have to do the mixed proportioning for the concrete as per IS 10262 2019 is the latest code book. But certain times in certain times we might have to adopt the nominal mix in the absence of proper data. We can go with the nominal mix if the grade of the concrete is less than M20. So in such a situation M20 cube shall be made, which has to be tested at the 28 days, at the age of 28 days, by doing some random sampling. So generally the sampling depends upon the quantity of the concrete poured. So if the quantity of the concrete work in cubic meter is between 1 to 5, the number of samples required is 1. If it is between 6 to 15, the number of sample required is 2. If between 16 to 30, it will be 3. If 31 to 50, 4. and greater than 50 and above 4 plus 1 for each additional of 50 cubic meter. So that's what our IS 456 specifies. So one samples means it consists of three specimens. Okay, each sample should consist of 3 specimen, and the variation allowed from specimen to specimen is around 15%. Okay, so based on that they have given one question in, I think, gate 2005 or 2003. So they mentioned that in a random sampling procedure for cube strength, of concrete, one sample consists of X number of specimens. Okay, so one sample, they have considered the one sample, it consists of X specimen. Okay, the specimens are tested at 28 days. So these specimens are tested at 28 days, and the average strength of this X specimen is considered as test results. Okay, so the average strength of these X specimens is 28 days. At the age of 28 days is considered as the actual strength. Okay, so that means FCK is equal to average strength of X specimen. Okay, average strength of X specimen is considered as test result of the sample, provided that individual variation in the strength of the specimen is not more than plus or minus Y%. Okay, so your average individual value of the each specimen should not be greater or lesser than plus or minus Y% of the average strength. Then what is the values of X and Y? So as per IS 456 2000, as I told you early, so one sample requires minimum 3 specimens. Okay, minimum 3 specimens. Generally, the average of 3 specimen will be considered as 28 days strength. Okay, then also the variation between the variation of compressive strength for each specimen should not vary more than or less than 15% of the average value. Suppose if your average compressive strength is 22 Newton per mm square, 15% of this is plus or minus 15% of 22 is around 15% means 3.3 Newton per mm square. Okay, so that means the individual compressive strength of each specimen should not be less than 18.7 MPa or 25.3 MPa. It should not exceed 25.3 and it should not come below 18.7. So that means the 15% variation is allowed. So the correct answer is 3 and 15, that is option D is the. So they are asking what is X and Y. So we have to test, in order to find out the compressive strength, we have to test minimum 3 samples, and the variation is allowed is around 15%. So the answer is option D, 3 and 15. So moving on, the properties of concrete, very important properties of concrete as per IS 456. So as per IS 456, the ordinary concrete means between the grade M10 to M20. So if they are mentioning the standard concrete means between the grade between M25 and M60 is considered as the standard concrete, and high strength concrete is nothing but grade greater than M65 to M100 will be considered as high strength concrete. So generally the flexural strength of the concrete is generally calculated using the formula 0.7 times of root FCK. So more in few of the gate examination, they have asked the question on this formula as well as Young's models of the concrete formula. Okay, so workability related issues are given in the amendment 1 of IS 456. So please refer the IS 456 amendment 1. So one of the problem asked in the GATE examination was the flexural strength of M30 grade concrete as per IS 456 2000 is. So whenever they say flexural strength, it should be equal to 0.7 times of root of secant. So 0.7 times of root 30. So it is root 30 into 0.7 is around 3.83 MPa. So the correct answer is option A, 3.83 MPa. So if they ask what is the Young's modulus of M30 grade concrete, then you have to consider 5000 root FCK. Okay, 5000 root FCK. So root 30 into 5000, which is around 27,386.12 Newton per mm square is the Young's modulus of M30 grade. So like this, they may ask you for 1 marks this type of questions. Okay. So there was another question as per IS 456 2000. Consider the following statement: the modular ratio considered in the working stress method depends upon the type of steel used. The type of steel is nothing but the grade of steel. Okay. The second equation, so this equation is not true because we know that M is equal to 280, equation for M is equal to 280 divided by 3 sigma CBC. Okay. So where sigma, it depends upon the grade of concrete but not on the grade of steel. Okay. So that's why the first statement is wrong. Okay. So there is an upper limit on the nominal shear stress in the beams even with the shear reinforcement due to possibility of crushing of concrete in diagonal compression. Okay, so this statement is always true. This statement is true because even though we provide whenever we have tau c value, whenever we have tau c value less than tau v, we have to provide a shear reinforcement. However, the tau c tau v value should be lesser than tau c max. Okay, so this always tau v should be always less than tau c max. So tau c max is nothing but it is the maximum permissible value in order to avoid the diagonal compression, avoid the crushing of concrete due to diagonal compression. Okay, so the statement 2 is right. The third statement given was a rectangular slab whose length is equal to its width may not be two-way slab for some of the support condition. Okay, so whenever we generally we say if the LY by LX ratio is less than or equal to 2, we will design it as a two-way slab. Okay, we will design it as a two-way slab. So this is true only in case all the four edges are, if the slab is resting on all the four edges. If all the four edges are resting on some of the support, then this equation, then we will design it as a two-way slab. In case any one of the edge is not supported by any of the support, then we don't design it as a two-way slab, we will design it as a one-way slab. So in case of cantilever slab and all, we don't design it as a two-way slab even though Ly by Lx ratio is less than or equal to 2. So the statement 3 is also true. So the true statement are only 1 and 2. So 1 is a wrong statement, so it cannot be an option A. Option B is only 2 and 3. Yes, it is only 2 and 3. Option C is only 1 and 3. So since 1 is a wrong statement, it cannot be the option C. All the three statements are right. No, because the statement 1 is wrong. So moving on, the working stress method of the design specifies the value of modular ratio M is equal to 280 by 3 sigma CBC, where sigma CBC is the allowable stress in bending compression in concrete. To what extent the above value of M make allowance for the creep of concrete. So as I told you in the first session, in the working stress method, the creep of the concrete in the long term has not been considered into the account. However, a partial compensation has been included in case of working stress method. So the allowance made in case of working stress method is partial compensation. There is a compensation, so it cannot be an option A, and also there is no full compensation, so it cannot be option B also, and those two are not unrelated. That is a wrong statement. So the correct answer is partial compensation. Okay, so moving on to the next next problem. So the maximum strain in an extreme fiber in the concrete and in the tension reinforcement of Fe415 and grade and ES is equal to 200 kilonewton per mm square in a balanced section at limit state of flexure or respectively dash. Okay, so we know that the maximum strain in concrete is always restricted to in case of flexure, it is restricted to 0.0035. In case of axial compression, it is 0.002. Okay, so these two you have to remember. 0.0035 in case of flexure and axial compression. Okay, so only in case of axial compression, it is 0.002. So concrete should so your maximum strain of concrete should be 0.005. So what you consider either option A and option B. In order to find out the maximum ultimate strain in case of steel, we have the equation 0.002, that is proof stress, plus Fy divided by ES into factor of safety. Okay, factor of safety. So we know that factor of safety is 1.15 for steel. So if you substitute this, it will become 0.002 plus 0.87 times of Fy. So Fy is 415 divided by 200 into 10 power 3 Newton per mm square, because everything is in terms of Newton per mm square. So 0.87 into 415 divided by 200 into 10 power 3 is 1.805 into 10 power minus 3 plus 0.002 is will be 0.0038. So the correct answer is option A. Option A, 0.0035, 0.0035 and 0.0038 is the correct answer. So few concepts which I have left out in the beam while covering the beam portions are slenderness of the beam. So generally, because why did I left out? Because it was not asked in the previous gate examination. However, you may expect a question in case of slenderness of beam. So what may be the question? They may give the cross section details. They may ask you to check whether the section is slender or not. Okay, so they may ask you to find out whether the section is slender or not. So how to find out? So the formulas for simply supported beam or a continuous beam is in case of simply supported beam and continuous beam, L allowable is lesser of the following. First one is 60 times of B, or 250 B square by D in case of simply supported beam. In case of cantilever beam, it is 25 B or 100 B squared by D, whichever is lesser. Whichever is lesser, that should be considered as the slenderness limit or the L allowable in case of beam. If does not satisfy the L allowable, if the L actual is greater than the L allowable, then your section will become slender. In such a cases, the beam may also buckle. Whenever there is a lateral forces, due to the lateral forces, the beam may also buckle. So that's why we have to check the slenderness limit. And in case of this may be asked in 1 marks question. So concrete in sea water or exposed directly along the sea coast shall be at least M. If it is a plain concrete, the minimum grade of concrete in case of structure which is in contact with sea water or exposed directly to the sea coast, the minimum grade of concrete for plain cement concrete is M20 and that of RCC is M30. Okay, so in general, the minimum grade of concrete to be used in case of reinforced concrete members is M20. Okay, so this is the minimum grade of concrete to be used as in the RCC structural elements. So whenever we use the RCC structural elements, the minimum grade is M20. Okay, next, control for the deflection. The deflection due to all loads except finishing and partition loads shall not exceed L by 250. So this is in any case it should not exceed L by 250 whenever the partition load and finishing load is not considered. Inclusive of partition and finishing load, the maximum deflection, the maximum allowable deflection is restricted to L by 350 or 20 mm, whichever is minimum. Okay, whichever is minimum, that should be the minimum deflection criteria in order to control the deflection. Okay, so the vertical deflection limit should be based on the basic value of L by D. For span up to 10 meter, these are the values. For cantilever, it is 7. Simply supported, it is 20. Continuous, it is 26. For span above 10 meter, the value given in the above may be multiplied by L by D in meters. Okay, say example, if the span is 12 meter for a simply supported beam, if the span is 12 meter. So in such a case, let us assume the depth is 500 mm. So L by D is 12 divided by 0.5, it will be 24. Okay, so 24 should be multiplied to 20. Okay, 24, sorry, this is, okay, L is 500. Okay, 12 divided by 500 is 6. Sorry, 12 divided by 500 is 0.024. You have to multiply. Sorry, for span about 10 meter, the values in A may be multiplied by L by D in meters. Okay, so you have to multiply L by D in meters to that value in order to get the allowable value. Okay, so summarizing all the values, so you have whatever the things you have to remember in case of singly reinforced is this equation: XU is equal to 0.87 FYAST divided by 0.36 FCKB to determine the depth of neutral axis. Then the values of XU max by D based on the various grades of the steel. So in the IS 456, 550 and 600 is not given, so which can be computed as 0.44 and 0.43 using the equation. using the equation. What is the equation? Equation is 0.0035 divided by 0.0055 plus Fy divided by Es. Okay, so this is the equation. With this equation, you can always compute the xu max by d value. Okay, so with this equation you can always find out the xu max by d. So the maximum compressive force in a concrete member is 0.36 fck b into xu in case of singly reinforced section. The maximum tension force is tu is equal to 0.87 fyast. The moment of resist, in order to determine the moment of resistance, if the tension force is predominating, multiply the tension force by lever arm distance. Lever arm distance is d minus 0.42 times of xu. Whenever the compression force is predominate, xu will become xu max, and you should multiply with the compressive force, and pt limit is equal to 41.4. And this one, the balanced section, the concept of balanced section, under reinforced section and over reinforced section is very important. If the xu is equal to xu max, we will call it as balanced section. In case of under reinforced, xu is always less than xu max. In case of over reinforced section, xu is always greater than xu max. So generally we prefer under reinforced section. Balanced section is an imaginary section. We cannot provide it practically. Certain times we may near to the balanced section, but generally we should always, while designing a structural member, we should provide the under reinforced section. We should design it as an under reinforced section. Okay, and also we discussed the few points related to minimum amount of AST in case of beam. What are the maximum amount of shear reinforcement? What are the maximum amount of shear reinforcement in case of spacing of maximum shear reinforcement spacing? Then also we discussed about the pond strand and doubly reinforced. In case of doubly reinforced section, you should remember the formula for maximum strain. Okay, so you can always remember the formula for maximum strain as 0.0035 into xu max minus d dash divided by xu max. Next, in order to find out the depth of neutral axis, you have to use the equation 0.36 fck b into xu plus fsc into asc is equal to 0.87 fyasc. In case of fe250 grade steel, you can always consider fsc as 0.87 times of f1. Okay, so then the equation total AST is comprises of AST1 and AST2. AST1 is the AST related to mu limit, and AST2 is the AST which is required to balance the compressive force, balance the excess moment. Thus, depending upon AST2, we will provide the amount of compression reinforcement using this equation. Then we discussed few problems related to axial columns, IS code recommendations. In case of slabs, the minimum amount of reinforcement is 0.15% of the total gross area, 0.15% of total gross area, and the diameter of the reinforcing bar shall not be, okay, so the diameter of the reinforcing bar shall not be greater than 1/8 of the thickness. Okay, say example, if the slab thickness is 150 mm, 150 divided by 8 is 150 divided by 8 is 18.75 mm. So your reinforcement diameter bar should not be greater than 18 mm diabars. So that is the one of the important provision to be remembered. So in case of column, minimum area is 0.8%, maximum area 6%. However, we will restrict it to 4%. So this is in case of no overlapping. In case of overlapping is allowed, the maximum percentage is 4%. So rectangular columns, 4 is the maximum rectangular number of reinforcement, and 6 is the minimum 4 bars has to be provided and minimum 6 bars has to be provided in case of rectangular and circular column respectively. So the bars shall not be less than 12 mm diameter, and spacing of the reinforcement along the periphery of the column shall not exceed 300 mm. So these are the few important aspects to be considered uh, in case of reinforced concrete structures. As far as possible, I have covered all the type of questions which was asked in the previous gate examination. So there may be a slight variation in the numerical values. And there may be a slight variation in the slight twist in the questions. The concept remains same. So always study the concepts. Even you can expect the questions related to effective length of the compression members. So generally for hinged sections it is 0.65. For fixed sections it is 0.65. For hinged case it is 1 times of L. If it is between hinge and one end is hinged, one end is fixed, it is 0.8 times of L, and one end is fixed and other end is free, it is 1.2 times of L. If one end is hinged and the other end is free and also not restrained, in such a cases it is 2 times of L. So I think in one of the gate examination they have asked an electric pole having a height of 6 meter, what is the effective length in such a case? So in such a case the bottom is fixed and it is restrained against the movement. It is restrained against the movement, but is allowed to rotate. It is allowed to rotate. In such a case, you have to consider 1.5 times of L as the actual effective length of the section. So that was one of the gate question as which I have not included in my presentation. So these are the some of the aspects to be remembered. Okay, so and also remember whenever they change the stress block parameter, always remember that in order to determine the compressive force, you have to find the area of the stress block, and after finding the area of the stress block, you find the average stress, by dividing it. Since it is acting over a depth of xu, we have to divide it by xu, so that you will get the average stress multiplied by the corresponding cross-sectional area. Okay, so you will get the total compressive force in case there is a change in shape of the stress block parameter. Generally, we will consider the stress block parameter to be a parabola and a rectangular. So this is the general equation, which is general assumption made in the IS 456. Okay, so these are the some of the aspect. There may be a questions related to concrete, like what are the tests, depending upon the say example, they will give the two list A consists of some of the tests, list B consists of why these tests are conducted. Say example, setting time, wicket apparatus. Okay, then to determine the workability, to determine the remoldability of the concrete, we should conduct VB consistometer. So like this, there will be a set of experiments and why we are going to conduct that experiment. So that may be asked in the gate examination related to concrete and reinforced concrete. Okay, so as far as possible, I have covered all the aspects which has been asked in the previous examination. All the best for the all the gate aspirants. Madhushri ma'am, over to you.
Thank you, sir. Thank you, Professor Arjun, sir. It was very informative session. I also thank all the audience for your listening. The link for the next session is in your WhatsApp group. Please go through the link. The next session will exactly start at 3:45 p.m. So we'll stay tuned and join exactly at 3:45 p.m. Thank you, everyone.